We continue with lashing. First, some physics behind friction. We can define the friction as a resistance against movement, slipping down to the lowest part. Friction plus the horizontal component of the lashing needs to deliver at least an opposing force equal to m times g times sinus of the list. In practice, on board, we use rubber dunnage with a friction coefficient between 0.45 and 0.6 when it's dry and degreased, and wooden beams have a lower friction coefficient somewhere between 0.25 and 0.35. So just to one more time define what we need to do when we do lashing. Together with friction in combination with the horizontal component of the lashing, and it's dependent on the hook over here, hook V. These two forces need to be at least the same as this one in the opposing direction. In that case, the object, in this case a collo, stays in its place, and that's what we intend when we do lashing on board of a ship. So, some rules of thumb. You should know the weight and the position of the vertical center of gravity of the piece. Know your lashing gear, know the maximum securing load per lashing, for example from a chain. Make sure there's enough space around the cargo, and that's due to this horizontal component of the lashing. Inspect the cargo. Are there enough lashing points, strong points to connect the lashing? Is there not any risk of tumbling over? And usually we use the lifting points also as lashing points. The weather, think about significant wave height and the height of the swell, because that's a good predictor of the amount of rolling and pitching the ship will do. Nevertheless, it's also dependent on the length of the GM. The surface of positioning, it needs to be strong enough, clean, not slippery and horizontally flush. Increase the friction coefficient by placing appropriate dunnage. And prior to placing a piece, we need to be aware that the surface where it's placed on, it's strong enough. So prepare the tank top load, twin deck load, or the hatch load. All items to be inspected should be accessible during the sea voyage, because we need to retighten lashings during the sea voyage once or twice a day. Chief mate and the bosun, they make a round and they double check all lashings. Don't make the stability too large, because the rolling period will be short and the dynamic loads on the lashings will be higher, maybe even severe. During the voyage, think about the ODA loop, anticipate on bad weather, prevent heavy rolling, and think days ahead. When you do your voyage planning navigationally, think about shelter, point of refuge, etc. And this starts already at the beginning of the voyage planning. So here's here's a small picture of types of web lashing. We will find the breaking strength and the maximum securing load. It's written on it in decanewton. 1 decanewton is 10 ordinary newton, and if we use G as 9.81, we can actually take the gravity away, basically, and it helps us calculating a bit more easy. What is important that the breaking strength is in relation to the maximum securing load. It's given, and there's some redundancy built inside the lashing itself. That's important to keep in mind. If we lift, we usually use safe working load, but basically it's more or less the same as maximum securing load. They are both can be used. As last, before we go to the last sheet, the next sheet, it's written at 4.4. When the components of a lashing device are connected in series, so they are combined, for example, a wire to a shackle to a deck eye, we need to think about the minimum MSL in the series. And that's actually the weakest link in the chain, so to speak. So de zwakste schakel in de combination of all. On web lashing, usually there's a small tag. Also on the ratchet, sometimes you can find something. On the blue tag, you can find information about the breaking strength and the maximum securing load. Important as a characteristic of a lashing to be chosen, you need to think about the elongation of the lashing, whether it's weather resistance or not, and how important it is. Is it easy to install and apply? If it's fire resistant or no, and whether we can easily jettison the cargo, especially from the weather deck. It might be a good thing that you are able to cut with an axe the lashing. That might be a good thing in certain cases. Whether lashings can damage. So the steel rolls are lashed with steel band. It's single used and it's pneumatically tightened. It's a very good way to lash, but it's single use. Here with bulldog clips, some lashings, and here chains. So the difference between standardized and non-standardized cargo. Standardized cargo is if a ship is outfitted with lashing arrangements for a certain cargo, that cargo in that case for that ship is a standardized cargo. Annex 13 gives guidelines for the lashing of non-standardized cargoes. We have three methods, and this year we going to speak about the simplified method only. And the alternative method in use, it needs to be approved by class bureau, but we speak a bit more about this in year number 3. So if we apply the simplified method out of Annex 13, not all the lashings placed on the four sides of a piece of cargo are actually taken into consideration into the method. So this loop lashing you see over here, it's extra, it's additionally, and we don't integrate it into this method itself. And lashing going over the top of the cargo unit, which have no defined securing direction, but only act to increase friction by their pre-tension, cannot be credited into the evaluation of securing arrangements under this annex. So we don't add them to the equation if we use the simplified method. When the components of a lashing device are connected in series, for example, a wire to a shackle to a deck eye, the minimum MSL applies. Well, I just mentioned you that, so it's the weakest link in the chain. That one we take into consideration in the evaluation of the simplified method for a piece of cargo. So the safety factor, when there's some insecurity about the tension in all the lashings, we can bring another safety factor into the equation, and we put more lashings or stronger lashings on the piece of cargo. That's actually what a safety factor implies. So here's actually the rule itself. It's actually pretty straightforward, and the most important parts are written down in item 1 and 3. The total MSL values of the securing devices on each side of a cargo unit, port as well as starboard side, should equal the weight of the unit. So, but what we only do is that we only count lashings with a lashing angle with this horizontal surface smaller than 60 degrees. If a lashing has a higher angle, we don't bring it into the calculation within the simplified method. Nevertheless, might be possible that an angle of 60 degrees is beneficiary to the total setup of the lashings, but we don't take it into the method itself. So we've placed a colo, that's basically a box of cargo. We put it on the surface. The colo weighs 7 ton, and that equals to 69 kilonewtons, and it means that on all 4 sides we're going to lash with 69 kilonewtons as well. Nevertheless, the lashings that are placed on the 4 sides should have a lashing angle smaller than 60 degrees with the horizontal surface where it's placed on. I hope you can imagine that on all 4 sides we put more than one lashing, and that's due to stability of the piece on the surface. Some more items concerning good seamanship. So the lashing angle of all the lashings smaller than 60 degrees. If it's higher, we don't count them with the rule of thumb. Lashings of the same material, so they have the same elongation, and in Dutch we can say de rek of the verlenging. That's what we mean with elongation. This rule of thumb implies normal conditions. If the weather is more severe or there's some other reason out of good seamanship to have more lashings or stronger lashings, we can imply this safety factor, and we just multiply the weights on all 4 sides. So in case we have excessive rolling, and they use 30 degrees rolling within this code, you need to change course up front. So prevent excessive rolling and be on time with changing course to a less severe roll. So navigation, think about the outer loop, think days ahead, points of refuge and shelter, and put them in your voyage planning. We need to have a balanced amount of lashings, and the smallest MSL if multiple parts are combined in one lashing. So we take the MSL or the SWL of the weakest link in a lashing. That's the one we count. Be aware of tipping over and sliding. So we might need some higher lashings to prevent tipping over or sliding. Arguments to apply more lashings or heavier lashings. Here they come. The length of the sea voyage and the accuracy of weather reports. So the longer the sea voyage, the less accurate the weather report you have prior departure will be. So the longer we sail, the more insecurity there is about the weather, and that might be a reason to bring this safety factor into play and put additional lashings on the items. Do we have a big GM? That's another reason to add more lashings to the setup. Coldness, and this has to do with the elongation and the brittleness of the lashings, especially if we use steel ones. Loading on the frames, the need to use wooden beams. So if you place a colo on the frames, on the stiffenings in the double bottom, we cannot use rubber dunnage. So we are actually forced to take wooden beams because we need the height of the dunnage. And wooden beams have a smaller friction coefficient, and we need to anticipate on that and add additional lashings to the setup in case we use wooden beams. That's it. See you the next one.